Okay, on the rest of these slides, I kind of call these formulas that you're going to get the chain rule version of the formula that you already know. And even though this probably isn't the ideal background or page for this, I'm going to remind you, or show you what I'm talking about. So the derivative of e to the x, is e to the x. But the derivative of e to the u is u prime e to the x. Okay, so we're going to run across a similar thing when we look at the derivative of the log. This slide, you can pause if you want to read through it. All it's really saying is that up until now, the derivatives of algebraic functions were algebraic. Derivatives of transcendental functions like sine have been transcendental, like cosine. And now they're just saying that, okay, we're going to look at the derivative of the natural log function, which is transcendental, and it's going to be an algebraic function. So you already know this formula, but it's definitely worth repeating again. The derivative of the natural log of x equals 1 over x. So the chain rule version of that is, I'll kind of write it in a different way down here. The derivative of the natural log of u, and I'm going to put the absolute value with it, is 1 over u times u prime. But a more efficient way to write it is u prime over u. That's definitely the way you want to see it. This little mark here, incidentally, is just a comma, that, telling you that u has to be greater than 0. Because if u wasn't greater than 0, it wouldn't have been in the domain of the natural log function. So again, 1 over u du dx, or 1 over u prime, or u prime over u. Those all mean the same thing, and I would definitely use u prime over u. Just seems like the easiest to remember. So let's use that for these problems. So the derivative of the natural log of x would be 1 over x, but since this isn't just an x, it's actually, a function of x, then we have to use the u prime over u, and u prime is 2, derivative of 2x is 2, and then it's over u, which is 2x. Cancel the 2's, and you have 1 over x. There was actually a different way that you could have done this. I guess might be worth mentioning. You could have rewritten that log using properties. The natural log of 2 plus the natural log of x. And then when you want to take its derivative, the natural log of 2 is just a constant, so its derivative is 0, and the derivative of the natural log of x is 1 over x. But I think u prime over u is probably quicker and easier. The next problem, the natural log of x squared plus 1. This is considered your u, so use u prime over u for your rule. The derivative of the natural log of u is u prime over u. And that's it. And if you can't simplify it, you don't simplify. In some of the problems, it's worth trying to simplify them. Okay, now what's different about these two? In this first one, we have the natural log of x, and then it's times x. So we're going to have to use a product rule. Maybe I'll do two different colors. So I'm going to do derivative of the first, which is just a 1, times the second, plus derivative of the second times the first. Derivative of the second is 1 over x times the first. So that's your product rule. F prime of x times g plus g prime of x times f. Okay, so now just simplify your function a little bit, as much as you can. So this is just going to equal the natural log of x, these cancel, plus 1. Okay, next problem. This one's a little bit different. You can think of this in a couple ways. First, I'll write it out kind of a longer way, where you're the function here, y equals the natural log of x cubed, can sort of be thought of as y equals u cubed, and then u equals the natural log of x. Do you see how if you put these together, if you put this in for the u here, you would end up with the natural log of x cubed. So the way you use the chain rule to find those derivatives is you take this derivative, you take this derivative, you multiply them together. 3 times 1 over x times u squared, there's my u squared, and then this just simplifies basically to what you're looking at. The other way to do the problem, I'm going to just get the same answer obviously, is I want to use the general power rule, which says that the derivative of a function to a power is the power times the function to the 1 less power times the derivative of the function. So let me do that right here. Pick a better color. So this is my n. So n times the function, I guess I could just write natural log of x, to the 1 less power times the derivative of the function. And you see these both give you the same answer. 3 times the natural log of x squared all over x. And all that this is pointing out is that it doesn't matter if there's an absolute value here or not. Either way, the derivative of the natural log of u is u prime over u. Okay, bases other than these. So the log, natural log has a log, base is a log. To differentiate logs with different bases, I told you that this was coming. You have this formula already. I gave it to you one day, but now this is the chain rule version of it. And if you want, instead of writing du dx, you can just write u prime. So it's the natural log of a times a to the u times u prime. And this is a new formula, so make sure you get this one down. The derivative of the log base a of x is 1 over the log base a times x. And you were kind of doing this with the natural log function, you just didn't think about this because the natural log of e is 1. And then this is the chain rule version. So it's 1 over the natural log of a times u, same as over here, except now you also have times du dx, which again, if you want, you can just write it as u prime. So it's just really u prime over u, and then there's also a natural log of a in the bottom. So on the next slide, let's use it. All right. Definitely have your rules in front of you to make this easier. Also, maybe pause before you try the problems. Okay, so for A, you try to follow your formulas and see if you get what I get. All right, so we want the natural log of A times A to the x. So you're just following the formula, and there's nothing you could do to simplify that. All right, now let's try this. Y equals, now the slight difference with this one is we have the 3x, not just the x. So this was an a to the x, this is an a to the u. So follow that rule. So now I'm going to have the natural log of 2, so the natural log of a, times a to the u times u prime. And this, I think, just doesn't look as good as it could look, so I'm going to move the 3 out front. 3 times the natural log of 2 times 2 to the 3x. And I kind of like how that one looks. Alright, last problem. This one might be tricky. This is the log base 10 of the cosine x, not times. I mean, at a glance it looks like a product rule, but it's not a product at all. Now, how do you find this? Well, I'm actually going to rewrite the formula for a second. The derivative of the log base A of x, in this case, no, it's not, of u, because this is actually what we're taking a log of, right? And it's not just a letter, is u prime over the natural log of a times, I'm going to make sure you know that's an a, times u. Okay, so my u prime, well, if this is my u, what is u prime? And I just realized I forgot a prime on this one. So my u prime is the derivative of cosine x. My natural log of a is going to be the natural log of 10. And the u is just the original term that was here, which is cosine x. Okay, so is there any way you can simplify this? There actually is. I mean, this answer is okay, but sine over sine should be familiar to you. I could keep the negative with the natural log of 10, so I could rewrite this answer as negative 1 over the natural log of 10 times, and I'm even going to change that 1 because I was going to say times tangent of x. Sine over cosine is tangent, so I'll just put it right on top. So negative tangent x over the natural log of 10, or negative 1 over the natural log of 10 times tangent x. Just pause and write down the formulas. You can get them out of your book or off of Paul's online notes, but definitely know all of these derivative rules. It goes up to the general power rule, and then these derivative rules also. Now notice these are all just in terms of x, so you might want to find them in terms of u, so you're also reminded to put the u prime in.